Good morning. Today we're going to talk about section 1.5 in our text entitled Solving Linear Equations. Again, this is a well-worn topic in your first course in algebra. Let me give you an example of what we're going after here. Well, roughly we're solving equations. Well, if I ask you to solve for x, I think we all know what to do here. We would probably add 4 to both sides, canceling the 4 out on the left-hand side, and then adds to 6 on the right-hand side, so 3x equals 10. And then to isolate x fully on one side of the equation, we would divide both sides by positive 3. Of course, the 3's would cancel out on the left, leaving me with an x residue on the left, and x equals 10/3 would be my final answer for this linear equation solution. Alright, so that was a baby one. Let's go up the ladder here. Solve. 2/3 b equals minus 15. Well, just like evaluating expressions, solving equations, equations don't always have whole numbers as coefficients. Sometimes you got to deal with fractions, right? Alright, what would we do here? I think I don't want to deal with the fractions if I don't have to. If I multiply by the least common multiple of all denominators in an equation, all the fractions will go away. And here you've only got one denominator, and that's 3, so I can very easily balance this equation by multiplying both sides by positive 3. Why positive 3? Because the 3's cancel out on the left-hand side, and then I've got a whole multiple of b on the left. So 2b equals then minus 45. And now to clean up b on the left-hand side, I would divide both sides by 2. 2's cancel on the left, and I get b equals minus 45 halves on the right. Now this is what I'd call the final answer here. It's completely simplified. Can't simplify it any further. And I'm not too crazy about decimals. Sometimes we have to deal with decimals, not yet in this course. And if your numerator is bigger than your denominator, we have what we call an improper fraction. And some of us like to convert to mixed numbers. We've got a whole number part and a fractional part. I'm not going to get into that either in this course. So regarding these equations, please no decimals as final answers unless necessary. We'll talk about that later. And no mixed numbers as a final answer. Okay? Let's try another one. Up the ladder we go. That's what this section is all about, solving equations. In some way, that's what this course is all about, solving equations. All right, you want to solve for x here, right? What I would do is, before I cross over the equality sign and doing things to both sides of the equation, I see some things I can simplify on the left-hand side, and I see some things I can combine on the right-hand side. So I always like to crunch things together as much as I can before I start crossing over the equality statement. Minus 6x plus 6x, well, of course, cancel out each other, so why deal with those if you don't have to? 1 plus 2x minus 5, that's equivalent to 2x minus 4, of course. Alright, I'm going to then add 4 to both sides. Remember, what you do to one side, if you do it to the other side, you maintain equality. And the goal is to do that while isolating x on one side of the equality and get a number or evaluate on the other. So 2x equals, on the left, minus 6 plus 4 is minus 12. And of course, dividing both sides by 2, I get x equals minus 6 as my final answer. Alright. On we go. Solve. All about solving equations today. Y plus 9 times y minus 5 equals 5 times 4y plus 1. All right. Clearly, I'm going to have to do some things here, perform some parenthetical multiplications to free up the y's to combine. Remember, you want to get all the y's combined on one side of the equation all by itself, and you want to do this doing algebra type things, namely adding, subtracting, multiplying, dividing. All right, let me multiply 9 times y minus 5 first, and I'll get 9y minus 45, applying, of course, my distributive law in that expression on the left-hand side. On the right-hand side, 5 times 4y plus 1, that's going to be 20y plus 5. All right. I can simplify even further here. Y plus 9y on the left-hand side is 10y. So 10y minus 45 equals 20y plus 5. Looks nice and neat. All right, I would probably subtract 10y from both sides. In that way, I'll isolate y on the right with a positive coefficient. And if I'm going to do that, I'd probably subtract 5 from both sides. Get my numerical coefficient on the left. All right, so I end up with minus 50 on the left and positive 10y on the right. If I divide both sides by 10 now, well, of course, minus 50 over 10 is minus 5. The 10's cancel on the right-hand side, and I get y equals negative 5 as a final answer. All right. All right, let's try something a little harder here. Let me get a fresh screen here. Hang on. All right. If I want to solve, I'll give you this one here. This one I believe is out of your book. Alright, so we've got some nastiness here. We've got parentheses operations. We've got nested parentheses. And what I'm going to do, I'm going to start attacking this on the left-hand side. I'm going to work from the inside out. So basically, I'm going to negate or multiply both these terms in this parentheses by -1, working my way from the inside out in my most nested set of parentheses. Alright, so minus 1 times 1 is -1. -1 times -3h is positive 3h. Alright, and I'll leave all other operations pending. Nice and slow. We'll take our time with this one. It's a little harder. Alright, again, focusing on the left-hand side, I'm going to focus on this set of brackets, or parentheses if you like. 3h plus h gives me 4h. So those h values are like terms. I'll get 4h minus 1 inside the brackets equals, and again, let me leave, that's a 5 there, other operations pending. Alright, now I've got to free up these h variables from their symbols of grouping, or parentheses. So I'll apply my distributive law. 10 times 4h is 40h, minus 10 times 1 is 10 on the left. On the right, minus 2 times 5h is minus 10h, and minus 2 times positive 25 is negative 50. Alright, so all the symbols of grouping are gone, and I've combined, at least within sides, as much as I can. I would probably then add 10h to both sides. That'll give me an h residue on the left, and if you're going to do that, you'd probably add 10 to both sides. Give me a constant on the right-hand side. So I end up with 50h equals minus 40. Dividing both sides by 50, I'll get, well, the 50s cancel out here on the left. I get h equals, and of course minus 40 over 50 reduces to minus 4/5. All right. All right, on we go. Let's talk about an equation that looks something like this. And again, the idea here is to solve 1/3 times 2x minus 1 equals 5/4 x plus 31/12. All right, now a lot of students here might panic. You've got an equation involving fractional multiples, even within stacked operations in parentheses, but don't panic on this type of problem. There's an easy way to get rid of these fractions. You don't have to deal with the fractions. Don't go diving to the calculator. You don't need it for this problem. What I'm going to do here is multiply both sides by the least common multiple of all these fractions. And of course, the LCM of 3 and 4 and 12 is of course 12. So I claim if I multiply all sides, on both sides, all terms by positive 12, all these fractions will go away. Watch what happens. All right, this is a product here. I'm going to multiply 12 times 1/3 first. Get rid of the fraction. 12 times 1/3 is, of course, 4. 3 cross cancels into 12 4 times. And I'll hold there, and I'll eventually multiply it by 4 on the left-hand side. Right? 12 cancels out the fraction of 1/3 on the left-hand side. Now on the right, we've got to apply our distributive law here. We've got two terms of a sum. Right? So I've got to multiply both by 12 independently. Well, let's cross cancel. 4 goes into 12 3 times, and 3 times 5x is 15x. Let me do that again. 4 cross cancels into 12 3 times, and 3 times 5x is 15x. Okay? Plus, how about 31/12 times 12? Remember, you've got to multiply both these fractions independently by 12. And of course, the 12s just cross cancel here, and I end up with 31. So it looks very nice already. 4 times 2x minus 1 equals 15x plus 31. With that somewhat complicated first step, I'm able to greatly simplify this problem into ones like we've done earlier today. Alright, so now applying my distributive law on the left-hand side, I get 8x minus 4 equals 15x plus 31 on the right. Alright, I suppose, well, I might subtract 8x from both sides. That'll give me an x residue on my right-hand side, and if I'm going to do that, I would probably subtract 31 from both sides. Alright, that will give me a result of minus 35 on the left-hand side equals positive 7x on the right-hand side. Dividing both sides by 7. The 7's cancel on the right, and I get, well, 35 over 7 is a 5, of course, so minus 35 over 7 is negative 5. So my final answer here is x equals negative 5. Alright, let's try one more. Again, involving fractions. Kind of a nasty one, kind of the upper limit of homework difficulty in this last one. I suppose we can do this one, you can do all of them. Solve 8/5 minus x plus 9 over 2 equals x plus 2 over 5 minus 4x. Alright. Similarly as in the last problem, I don't want to deal with these fractional values. And I don't have to if I multiply by the LCM. Well, you've got really three fractions here with denominators of 5, 2, 5, and really 1, respectively. And the least common multiple of 5 and 2 and 5 is, of course, 10. So if I multiply both equations through by positive 10, the fractions will go away, and I'll be able to turn it into a problem much like the easier ones we've done today. Alright, 10 times 8/5. Remember, you've got to apply your distributive law to both terms of this difference independently. 5 goes into 10 twice, and 2 times 8 is 16. Minus 2 goes into 10 5 times, and 5 times x plus 9, well, I'll tell you what, I'm just going to leave it right there as 5 times x plus 9 and worry about it later. On the right, again, distributive law. 10 times 4x over 1, well, that's just minus 40x. Well, I'll tell you what, to make it a little more clear, I'm going to multiply 10 by x plus 2 over 5 first. 5 goes into 10 twice, and 2 times x plus 2 I'll worry about in a minute. Minus. Well, 1 goes into 10 10 times. 10 times minus 4x is minus 40x. All the fractions are gone, and something a little easier to deal with now. Of course, I've got to unchain those variable values from their symbols of grouping in order to combine. 16 minus 5x minus 45 equals 2x plus 4 minus 40x. Looks good. Again, let me simplify within sides before I start crossing over the equality sign. 16 minus 45, of course, combines to a minus 29. And 2x plus 4 minus 40x, well, of course, 2x and minus 40x are like terms and combine to a minus 38x plus 4. Alright, I would probably add 38x to both sides. Get my x residue on the left. And then I would probably add 29 to both sides. Get my constant value on the right. So I end up on the left with 33x equals 29 plus 4 is, of course, 33. Well, that's convenient. So 33x equals 33. If you don't see it right away, well, I'll divide both sides by positive 33. The 33's cancel out on the left-hand side. I get x on the left equals, and of course 33 over 33 reduces to 1. So my final answer for this problem is x equals 1. Alright, so we've solved about 10 of these linear equalities today in section 1.5. We're approaching the 20-minute point, so we'll call it a day. And this concludes section 1.5, solving linear equations.